So I'd like to welcome Jason Gould from Pamarco and thank him very much for sponsoring today's event.
No, I'll be okay. Yeah, thanks. Thanks, Tim. Hopefully not a 1 minute limit this time. Just firstly, it's an absolute privilege to speak to the SBA today. It's an awesome opportunity, so thank you very much. And without any further ado, Pamarco. So as I mentioned before, I started at Pamarco roughly a year ago, originally from South Africa. I look after the UK market, Ireland, and also South Africa through an agent network. And just a little bit of background history about Pamarco is that, or not background yet, just our footprint. We have 10 manufacturing sites worldwide, of which 3 are in the UK, 7 in the US, where we manufacture anything from engraved rolls to chrome rolls to analoxes to jumbos to bases, and then also the Absolute is also part of our Pamarco family as well. And the rest of our footprint is run through agent networks. As you can see, we sell to more than 100 countries, over 230 employees. And Pamarco has always been an innovator. So this is the history part. In the late 1930s, Pamarco was the first to chemically etch an analox roll. That was also patented in the in the US. And in the late 1970s, Pamarco was the first to engrave into ceramic with a CO2 laser, which was also patented in the US. And ever since that, those early days, we've innovated, whether it was through technical means or through acquisitions as well. Today and tomorrow, as you can see, in 2009, most of you know what our E-flow engraving is, our 75-degree E-flow. Changed the way densities appeared after printing, to do with cleaning, improved ink release. And then later down the line in 2015, we introduced our E-flow UV or E-flow Plus, and as well as our Easy Flow. This is a common question I get asked. You know, an analox is just an analox. But when you delve a little bit deeper into how it's made and why, it's not quite so simple. You get an analox and you get an analox. So how is an analox made? Just in a nutshell, whether it's new or refurbished, we'll prepare the roll for ceramic. So we will grit blast the roll to get rid of any oil residues, fingerprints, and any imperfections, and obviously the old ceramic as well through a grind. We will plasma spray it with a barrier coat and then also chrome oxide, which is your ceramic. We'll polish it, we'll engrave it, we'll prepare it for printing, which is our post-polish process. Sounds easy, doesn't it? It's not quite that easy. So part of Pamarco's values and principle is that of innovation and empowerment. So when we innovate, we like to be audited by independents. So what I'm going to go through now of what our innovation is in the last 3 years, it was independently audited by 3 different certified laboratories. And we drove this process through continuous improvements from what we've done. So you can innovate in different ways, new products or continuous improvement. So what we wanted to do was perfect what we already did and make it as good as we can. So our measured criteria was porosity. I'll also explain that why. And then coating hardness, thickness, and coating density, and what that means when it comes to a printing analogs. Excuse me. So over the last 3 years, COVID has also given us opportunities. So without being able to get out into the field because of, I don't know, the spreading of COVID, we sort of got stuck into our manufacturing process, and this is what drove our innovation, is that we are now achieving in excess of 1,400 Vickers in hardness, and also a porosity level of anything between 0.4 and 0.7%. What does that mean? Okay, I will get to that. Part of the process of spraying is it's a plasma spray, so we use ceramic particles or granules, and we spray it at high velocity through a very hot plasma spray or flame. I think it's about 1500 degrees Celsius, and we apply it onto a roll that's turning. And to be able to control that is not that easy. So ceramic by nature is porous because you're putting down a lot of little granules all at the same time, and it's the ability to control that so you minimize any sort of, if you want to call it, air bubbles in the process. And that's measured through an X-ray. One of our laboratories gave us feedback to say the type of spraying level that we are doing now is of aerospace quality, and it's the best coatings that I've ever seen in the laboratories. Once again, all independently verified. So here's the money question: what does it mean to the printers? Okay. So when you talk about hardness and density, its ability to put down the chrome with as little air bubbles, if you want to call it, as possible, or gaps. A lot of the time they are filled with a type of a sealant. We believe in a slightly different way. So when you have a lower porosity and a much harder ceramic, you will get better wear out of your analogs. The way we finish an analogs, I call our post-polish process. We prepare the surface of the analogs for the chamber blade, and if that's prepared evenly, your chamber blade's got a good landing area. So you'll also not, or you'll reduce the chance of having score marks and chipping off little bits of ceramic that are left behind after engraving and polishing. When you're putting down the ceramic as hard and as smooth as we are now doing it, the inside of the cell is also as smooth as it can possibly get, which means you get the maximum ink release. Okay, so often when people turn around and they say we can save you money with analoxes, you sort of try and figure that out, but at the end of the day we can actually reduce your volume slightly to get you the same density you were getting, but thereby saving you ink. Okay? You also stand a much smaller chance of staining and contamination, so nothing can actually penetrate the ceramic and get to your base and start corrosion. Because I'm sure some of you at some point in your life have seen what corrosion does to analox rolls. When ceramic is dense, you also engrave a lot easier into it, which means you're able to shape your cells a lot more uniform and consistent, and it's almost like golf. If your swing is the same every single time, you're actually quite a good golfer. The same goes for not making analoxes, but in principle, it's all about consistency. So when we can make the same roller time in, time out, the same every single time, you create that consistency in the market, and that's what the 77 years of manufacturing of what Pamarco has done, and that's our pride, is consistency and quality. Okay. So what makes a quality analox? This is a question I get asked a lot. We don't need to spend money on analoxes. We don't need a high quality. We're only printing block work. But that's not what we talk about sometimes. So a high LPI doesn't make a quality analox. A quality analox is one that delivers the same amount of ink day in, day out, when it's looked after and cleaned, of course. It lasts the longest. So it's not quite a capex, but it's still quite an asset. So you want to enjoy the full lifespan of it because it needs to make you money. So that's what we are trying to achieve here. So a high LPI or a high resolution doesn't make it a quality analox. Quality analox will last, will meter the ink correctly, will not get corroded or damaged as easily. Good ink release, accurate and consistent metering, reduced doctor blade wear, quality raw materials. We do not sacrifice quality for price. Okay, we are deemed to be a high quality analox manufacturer, which we stand by. And that's driven through innovation and the passion of the staff that work for Pamarco. Do you have any questions?
Thank you, Jason.
It's a pleasure.